We will now turn our focus to factoring polynomials. Factoring polynomials is the opposite of multiplying. You probably have heard this, right? If I wanted to find the factors of, let's say, the number 12, I have to think of what numbers multiply to be 12. So maybe 2 times 6, or 3 times 4, or 1 times 12, right? So the factors of 12 are 1, 2, 3, 4, 6, and 12. But to factor means to write something as a product, to express as a product. So think of this kind of like a Jeopardy question, right? You're going to be given the polynomial and you have to come up with what did you have to multiply to get that polynomial. And there are some steps to factor a polynomial. We can factor out a greatest common factor if it exists, and we want to do that first. If the polynomial is a binomial, there's really only a few things that will apply to binomials. It might have a common factor, or it could be in one of these forms. It could be the difference of two squares, which is a squared minus b squared equals a minus b times a plus b. Remember that product of conjugates gives us a difference of squares. Could be the sum or difference of two cubes. So a cubed minus b cubed is that a minus b times a squared plus ab plus b squared. A cubed plus b cubed is a plus b times a squared minus ab plus b squared. I have some students that think of the word SOAP to help them remember the signs. It stands for the same. The first sign is the same. Then the opposite. And then the last sign is always positive. And that's true if we're doing sum or difference of cubes. Now, to recognize the sum or difference of cubes or difference of squares, you have to really know your cubes and your squares. So just to kind of remind you of that, some perfect squares are 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and so on. For the perfect cubes, 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed, 4 times 4 times 4 is 64, 5 cubed is 125, and so on. Now, if the polynomial is a trinomial, we're going to try to find two binomials whose product is that trinomial. So thinking about doing reverse FOIL. And if the polynomial has 4 terms, we're going to use something called grouping to factor. So now we're going to look at some examples of each of these to hopefully give you some understanding of that. I have 2y squared minus 4y. So the first thing that I want to look at is, are there some things that are common to each of the terms? And if I look at between 2 and 4, 2 is a number that divides both of those. Between y squared and y, there's a y in both. So we're going to factor out. So factoring out is almost like applying the distributive property in reverse. So I'm looking at this a as the common factor, and the b plus c is what remains after I divide by a. So if I divide 2y squared by 2y, I'm just going to get y. And negative 4y divided by 2y gives me 2. And if you need to write those out explicitly, you can certainly do that. And I can always check factoring by multiplying it out. If I distribute the 2y through, I should get exactly what I started with. Now 25x squared minus 49, this is a binomial. There's not a common factor between those terms, but notice that 25x squared and 49 is a perfect squared. 25x squared is really 5x squared, and 49 is 7 squared. And so if you remember, the difference of two squares came up from the product of conjugates. The conjugates were the sum and difference of the same two terms, and the terms are what we have to square to get those original terms of the binomial. So it's going to be 5x minus 7 times 5x plus 7. And again, I can FOIL that out to see that I get the original expression. 8a cubed plus 1. This is a binomial. Again, there's no common factor, but I notice that 8a cubed is a perfect cube. In fact, if I cube 2a, I get 8a cubed. 1 is a perfect cube. If I cube 1, I get 1. So this is where I'm going to apply that pattern that would be helpful if you memorize. The a plus b times a squared minus ab plus b squared. So my a and b are what do I have to cube to get the original terms? And that was 2a plus 1. My trinomial is now manipulating these values of a and b. I have to square everything in the place of a. So if I square 2 and a, I get 4a squared. Then I have to take the opposite sign. Now I have to do a times b. So 2a times 1 is 2a. The last sign is always positive, and then I have to square what was in the place of b, which is squaring 1, to get 1. If I distribute all of that out, I'll come up with the 8a cubed plus 1. Now let's look at a trinomial. X squared minus x minus 42. There's no common factor between those terms, so what I want to do right now is think about what is the number, or sorry, what are the things that I can multiply together to get this trinomial. And if you remember, the first two terms are what gave me that x squared. So I know x times x is going to be the x squared. The last two terms are what gives me this negative 42. So the negative 42, I have to find two numbers whose product is negative 42, but the outer and inner have to combine to be this middle term. And so when I add those factors, their sum has to be a negative 1. So if I think about all the things that multiply to be 42, 1 and 42, 2 and 21, 3 and 14, and 6 and 7. The only ones that I can get a sum to be negative 1 is the 6 and 7. That's because to get a negative 42, I have to have opposite signs, right? A positive times a negative. And so for their sum to be negative, the larger one needs to be negative, the smaller one positive. And so my factorization will be x plus 6 times x minus 7. And I can check my outer is negative 7x, my inner is 6x, and when I add them together I get negative 1x. Here's another polynomial, 4x squared minus 8x minus 5. This one's a little bit different because I have something other than a 1 in the position of this leading coefficient. I have a 4. So I have to think about what are the factors of 4. So I could have a 4 and 1, or I could have a 2 and 2. And then my last term has to be the factors of this negative 5. So I know I'm going to have a 1 and 5, and one of them will be positive and one will be negative. So there's a method called trial and error, or guess and check, that can give you the right answer. What you have to do in that case is just continue looking at all the different possibilities. If I put in 4x and x, and let's say I put a 1 and 5 in, So I know my 4x squared checks. My 1 times 5 will give me 5. But I have to look at the outer and the inner. 20x and x will not give me an 8 in any way. So that one won't work. So then I have to think about, well, maybe rearranging these. Keep the 4x and the x and put the 5 and 1. But there the outer is 4x, the inner is 5x. I cannot get an 8x. So that won't work. So then I have to use the factors of 4 that are 2 and 2 and put a 1 and a 5. Now notice the outer is a 10x and the inner is a 2x. So from 10 and 2 I can get 8. I need to get a negative 8, so the larger one needs to be negative and the smaller one positive. So for the larger one to be negative, I have to put a negative on the 5 and a plus on the 1. So that is the correct factored form. Now let me look at 3ab minus 6a plus 5b minus 10. This is a polynomial that has 4 terms, and so I have to apply grouping. Grouping means that I have to pair together the first two and the last two and see if I can somehow get a common binomial from factoring. In the first two, 3ab and 6a, there's a 3 that divides both of those as well as an a. If I take a 3a out of 3ab, I'm just left with b. A 3a into 6a is going to leave a minus 2. For the second pair of terms, 5b minus 10, notice there's a 5 that goes into both of those terms. So I'm going to write this as plus 5. 5 into 5b leaves a b. 5 into negative 10 leaves a negative 2. So this is not yet factored because there's a sum, but now notice that I have a common factor in each of those terms, and so we can factor that b minus 2 out. And if I take a b minus 2 out of this first term, that just leaves a 3a. A b minus 2 out of the second term is going to leave a plus 5. So I'm going to show you more examples on the prerequisite check worksheet for this section, but hopefully that gives you at least an idea of what you're going to be working on when you have to factor polynomials. Stay tuned for more videos on this topic. Thanks.